Okay guys, we are back. Let's try to fix this issue, which is I have calculated the minimum for each sector. Nevertheless, they don't show the real because it was Leclerc. I don't know if I am getting the data. It should be, yeah, for Las Vegas Grand Prix qualifying 2023. Let me check here. Yeah, it should be fine. Yeah, here they say the. Okay, let me check for the time to see if Leclerc was on some. Yeah, I think this should be the best. Now everything makes sense. Nevertheless, it doesn't make sense for the third sector. Let me check. I'm gonna make a join. Okay. So theoretically this should be the best. Although ALB was the fastest in the third sector. Although they say Carlos Sainz. Let's continue anyway. Yeah, so this should be the minimum, and by the time that we subtract, let's see how it does it. So if we execute, here we don't get anything because there wasn't any gap. I think it should be working well. The bad thing is that we barely get data from the others. Okay. I think it's because it's rounding up the numbers. But here we have 31 seconds. For the second we have 30 seconds. We should have a higher difference. No, this is correct. Yeah, should be fine. The problem, I think, it's on the seconds that we should get nanoseconds. We are getting the number of seconds. Okay, let's do one thing. Let's get the total seconds. Yeah, now this is correct, more accurate. And now there should be, for variable, this doesn't make too much sense. Let me check. Okay. I think now I get it. Yeah. We should lambda x dt total seconds. This is the data we are looking for. Now there we get it. Finally. Yes. Now what else can we do here? There was, to tell you a bit of background, there was a problem because we had to move the information to be in total seconds before applying the melt. Otherwise, it would mismatch the seconds and the timing. So now I would like to add the information for the personal best lap. So the personal best lap well, I can calculate it down below. Let's go for is personal best, if it's true. And now for each driver we group by and calculate in the time the minimum. This should be the best one. No, time, I think it's the total time they were on the lap time. Yeah, this sounds more accurate. So now let's get to transform this into total seconds. And now we should calculate the ideal overall lap, which should be the minimum although the numbers do not coincide. I think because for this they are taking the best minimum, they are summing the information. There we get it. This is the number they have here. So we should compare the best lap the best minimum, and this is what we should put now in the plot with a line. Therefore, fig, we're going to add a trace for we need to sort the information, otherwise, so based on the Sadly, I'm still mixing the positions. Yeah. Ta, 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 ta. So I want to reorder the lines so that they align with each bar. And we have a problem because in this figure we are using the DFF and we should get the unique drivers instead of dropping the duplicates. But for the best minimum we should reorder in the same order they are here. Let me check if I can get into the properties of the figure data. The first elements, the Y, yeah, now it should be okay. Let's execute from the beginning. And there we have it. Now, which other thing could I do? Because I would like to reorder the x-axis. Let me check. I would like to reorder in a specific point. Concretely here. So I think we should reset the index. And now group by each driver and get the value sum. We sort the values, we get the order, driver, access the index, and now within DFF we can set the index for the driver again and locate by order driver. But I want the others at the top. So now the slowest one is at the top. I want to reverse, so I need to go to the order driver and put -1 so that the order is turned upside down. We place it here, execute again, et voila. Now we execute everything, and there we can get the same type of plot that they did to the right. There are many more things to optimize, but I don't want to extend the live stream more, so I'm gonna wrap up this code and share it with you in a link. Let me put some titles. Download data. For the Grand Prix. Now select sector columns. Now this time this is data preprocessing, and the first thing we do is to get fastest sectors per driver. Now we get the best, fastest sector. The minimum, the subtraction, which is the gap to ideal or to fastest, gap time, and finally here, yeah, convert to seconds. Reshaping dataset. Renaming values, we could say. Sorting data. And now data visualization. Which at the beginning is bar plots. Well, we could say, yeah, bar plots ranking, and then best lab. Now this is also part of data pre-processing, so we should move it to this part. And in best minimum, I think we should put gonna put this template to Plotly dark, and any other thing that we could do here is to change the legend, which here can be name, personal best lab. Yeah. And another thing we could do is to put this dashing line in the plot. So Plotly graph objects dash line. Yeah. I think here we should get the, I am understanding that we need to get two traces so that we can get the dot and the dash, but there should be one way to include dash dot. Okay, so in here we are going to use dash dot. We don't have it. Okay, because it's inside the line and we need to use the, okay, so we move this here, and now for the line we create a dictionary dash dot. There we have it. Set up a width of 4 and the color is put green on hexadecimal code. RGB 00 GFF00. Okay, and then last but not least, let's put all of these plots in the same line. Et voila, the layout. Let's maybe decrease the size. Okay, I think it's the width. Should put it to 2. Yeah, this is best. And the dots, I want to make it bigger. Yeah, I think they are adding a new scatter. So we shall do the same. I would like to put this dot, and I should be right. Maybe what I should not put is the line. Yeah, the line and the marker. So I think we can change the line on one hand, and then we change the marker on the other hand, and we can put the size to be 4. El Richie. A ver, aquí. O sea, para completar la gráfica me gustaría colocar un punto grande que se vea en cada uno de los mejores de la línea verde de cada conductor of each driver. I was talking in Spanish. So I want to place a dot, a big dot, in each dot according to the driver. So I'm looking how in this line of code I can put that, because if I am using the marker property and I am increasing the size to be 100, nonetheless I am not getting this option. Maybe if I remove this, but no. So I'm gonna see Plotly, graph objects, increase line and dot size. No. Let's go to ChatGPT. Okay, I need to put line plus markers. So line plus markers. Now it's huge, so let's decrease it. And there, I think we have a good one. Let's modify the more compact. And now let's modify the legend, which is gap to overall ideal lap. And this was already calculated here. So I'm gonna use an SF trim, place it here. And last but not least, let's change the title of the legend. Legend title text. They have it. Well, they don't have actually anything, but I would like to put here sector and finally a title which could be the same. "2023 Las Vegas GP qualifying." And now at the end, normally I would like to put some margin so that the chart is more at the inside, not that much. So what I might do is I'm gonna take this to the bottom and let's put too big. Yeah, I think this is quite good. Now, how can I put the plot more insights or adding some gap? Well, this is too much. No, it doesn't convince me. Yeah, so I'm gonna upload it as it is. Maybe I'm gonna add a legend. For the plot. And this is Dayton's. But Yeah, I think this is pretty good. Now let's put some color, gray. Yeah. And last but not least, let's put it into an image. Let's call it gap. Let's increase the quality. Yes, I think this might be right. So let me give you a quick summary of what we have done today. Let me place the links. So, inspired by this data visualization, and this code, we have reproduced the Python code in the following script. So, what have we done? At the beginning, I wanted to see some reference to see which was a possible visualization to develop in Formula One. I know that a person has already channeled F1 data analysis, and I got this visualization that I wanted to replicate. What does this data visualization illustrate? In the x-axis, we can see the number of seconds that each driver in the y-axis has in their best lab for each sector. Remember that in Formula One we have in the same circuit different sectors, and for each driver we are calculating the fastest time for each sector. For each sector we compare the driver to the best between all of the drivers, and that difference is the one plot in this chart in each bar by each sector, and the green line represents the overall best personal lap and the best of between all of the drivers. In the Python code, to replicate the visualization, we had to download first the data from the library FastF1. So we referenced this code, the library FastF1. We got the session for Las Vegas qualifying. We loaded the information and get the driver data. And that's the data frame we have here. In total, the drivers performed 3.5 laps, 100. Then we select the columns we are interested, the driver and the sectors. For data preprocessing, we need to follow many steps, such as calculating the fastest lap with the minimum and grouping by each driver. There we get the 20 drivers, and for each sector, the fastest lap. Then we here select the best minimum across all of the drivers so that they are subtracted to see the difference between the fastest lap, the fastest time for each sector, and the fastest for each driver. And that's how we calculate the difference. We convert the solution to seconds. Then we put the dataset from a wide format to a long format so that we can use it better for the data visualization. But first, I don't want to have sector 3 time in the legend of the plot. That's why I am only getting the sector S1, as you can see here, S1. And finally, I am sorting the dataset so that later in the plot we can see the visualization that the fastest drivers are at the top. What else did we do? The gap to best lap. We had to calculate this for each driver to see the difference between the fastest lap of the driver and the overall fastest possible lap. There we get the array, and with the Plotly library we create first a bar plot, which is the bars that you can see here, and to add this new line we have to add this scatter, and then I added some extra information to the plot with the update layout, such as the x-axis title, legend title, etc. And finally, to add the signature, which is here, Dayton's. And that has been for today's live streaming. I hope that you enjoyed, and let me know in the comments which other ideas you might have on other type of datasets, such as NBA, football, the stock market, whatsoever. And yeah, I am really open to do occasionally live streamings, so let me know if you're interested on joining. Maybe we can do a live session where I can teach you some tricks while we develop the code for a practical case. So have a good one and take care. Bye bye.